Closures are an important quality control step in the completion of a legal survey drawing. It is important to be certain that missing or incorrect dimensions are corrected prior to the final document being submitted for registration. As important as this step is, most of us would rather not spend a ton of time on it. The SGS Closures program is designed to make this step quick and easy from inside your CAD program, and it produces a nice HTML report on completion for your records. There are two commands included: close lot and close strata. The close lot command is designed for a typical lot closure, where the dimensions include bearings and distances for straight segments and some variation of information for curved segments depending on your region. Close strata command is designed for checking dimensions of a strata lot or condo, where typically only the distances are provided and corners are most often square. Let's start with a close lot command, which will be demonstrated with a quick example. Following this, we will review the available settings and describe some of the smart decisions that the program makes during the closure. To begin, just type the command name, close lot. The first prompt asks for the starting point for the closure report, and which can be any corner around the perimeter. We'll pick this corner here. The coordinates of that corner are printed to the command line, and the first prompt now asks for the bearing text, and of course there's some other options included here. Split bearing, which allows you to pick a bearing that is split into 3 components: degrees, minutes, and seconds. You can input a bearing manually by typing it. Usually that will not be required, but it's an option. The option to define a curve, we'll go into that next. Finish once you're completed, and redraw, which draws the temporary lines again once if you have zoomed around in the drawing and they are no longer visible, and undo removes the last segment that was added. So typically you'll just go ahead and select the first bearing of the line, and as you'll see, there's a highlighted yellow line being drawn here. This will remain until you zoom out again or pan around in the drawing. And then the next prompt asks for the distance text, which we will select here, and this completes the first segment. The temporary line is now drawn in solid and magenta color here. Now, just to demonstrate, if you pan or zoom, that gets lost. This is where the redraw function comes in handy. Next, we want to enter a curve. So we pick the curve from the selection, or type C in the command line. And the curve direction is the first thing that the command asks for. This could be left or right, left being counterclockwise, right being clockwise. So in this case, we're going clockwise. And we will be defining the radial bearing in this example. So we can simply pick on the radial bearing text, select the radius text, we zoom in, the radius text there, then select the arc length, and this completes the curve. The chord of the curve that we have defined will be drawn once all the parameters have been provided. And now the command returns to prompt for a bearing text entity. So we can simply go pick the bearing, pick the distance, pick the bearing, pick the distance, pick the bearing, and pick the distance. This completes our closure. So we can type F on the command line or select finish. There's a dialog showing the misclose of the closure, which in this case is 1.1 millimeters, which is acceptable in this case. Therefore, I will enter the description for this lot, which is lot B, and click yes to create the report. A dialog prompts you to specify the file name, which by default will be the drawing name, followed by a space, and then the description that you provided. You can click save, and the closure report is opened in your default browser. And again, here just to go over the contents of the report, the drawing name is in the title. The description is underneath here as a subtitle. And your precision, the length of the perimeter, the area, and the misclose information is listed here. And the diagram of the lot is shown beneath it. And on the right, we have a table showing all the segment information that was used to compute this closure. For curves, in this case, the radial bearing out is shown. It's calculated from the radius and the arc length that were provided. You can use that information to double check in your drawing that, yes, those do match. And at the bottom, there is a timestamp for the closure report, and the notation of which direction the segments were entered. The format of the report is such that you should be able to print this neatly on a letter size sheet. Now, as we were going around the perimeter, you may have noticed that this bearing is actually 0.5644, which would be in that direction. However, the program was automatically determining that no, we actually want to go in this direction. And the way it's doing that is it's looking at the endpoint of the previous segment and then the relative location of the actual text entity in relation to that endpoint, and determines whether or not to reverse this direction to 180 degrees 56 minutes 44 seconds, which is what happened there and also here. Let's go over the settings, which we have skipped over on the first run. This dialog will always be shown. But if we go close lot, there's an option to open the settings dialog. So if we click that or type S for settings, the lot closure setup dialog is shown. And here are the various settings that the program includes. Unit settings is the first group. Here you can specify whether your distance unit is in meters or feet. For the meter and foot symbol, it's just the suffix after the distance. If there is some in your drawings, for meters it can be an M or nothing. For feet, again, nothing, or the FT or the single apostrophe symbol. And for the bearings, are your bearings north bearings or 360 degree bearings as in the example, or quadrant bearings. The curve settings, the first parameter of a curve is always going to be the radius. That's a requirement. However, the second parameter can be the arc or the chord. And the bearings of the curve can either be radial, as in the example, or they can be chord bearings. And for the labels, this is the prefix. For example, the lowercase r equals, which is the setting that is specified here. You can set these to whatever you use in your drawings. And then lastly, there's some color settings for the highlighting. As you saw the bearings, there's a highlighted bearing drawn as soon as you pick a bearing. here's the color setting for it, and likewise once a segment is defined, the solid color is configured through the setting here. Now for the close strata command, again to start, simply type the command name. Again, the settings option is there, however there's less of those settings applied to this command. So to start, pick a corner to start, and the first prompt is pick the next distance text, where we simply pick the distance. Now once we've selected at least one distance text, we have a couple of options. So we can reverse that direction of that line if we wanted to. Just to demonstrate, that's how it works. We could undo it, we can redraw if you've zoomed around, and we can finish if once we've entered the last segment. But then really the idea is we simply pick the distances along the perimeter, and the program will automatically determine where the line should be drawn to. Now here's an example where the program will actually draw the segment in the opposite direction, because the location of this text entity is on this side of that last segment line and not on that side where the actual very short segment is. So when you pick it, we can see it's been drawn incorrectly. If we go reverse, now it's correct. We continue around the perimeter until we reach the final segment, and F in the command line or finish to complete it. Again, here's our misclose. It should be 0. Everything should be square, and it all should add up perfectly. And if that is the case, we can enter a description for this closure, and yes to save the closure report. Again, we are prompted to enter the file name, the same convention, drawing file name, followed by the description, save, and the report opens up in your default web browser. Same content, misclose the precision, which is infinity because there's no error in this case. The length of the perimeter, the area, misclose, which is non-existent here, diagram, the segment information, and the timestamp. So here for a strata, because everything should be square and the directions of these lines are actually determined by the rotation of the text entity in the drawing, we can do in the report is go through each line here, and the minutes and seconds of each direction should be identical, and anything that is different should jump out here, which would allow you to then go back into the drawing and fix the geometry, relabel that segment and potentially the adjoining segments, and then rerun the closure program to finish it up. So very simple, very quick, very helpful to avoid mistakes. Thank you for watching. If you would like some more information about these programs, you can email us at the email address shown or visit our website. These programs will run inside any CAD program that can run Lisp programs, which would include IntelliCAD-based CAD software like Microservic CAD or Carlson, AutoCAD, and BricsCAD, and potentially some others.